15.2, part-way segment. Point A has coordinates 2, 4. Point B has coordinates 8, 1. Question 1, find the point that partitions segment AB in a 2-to-1 ratio. So, this topic is known as directed line segments. Okay, because we're trying to find in the direction from A to B, where on this line could I put a point that would cut that line segment so that the two segments create a ratio of 2-to-1. So what does that mean to create a ratio of 2-to-1? Well, it's to create a weighted average. Well, what does that mean? Well, we just found averages, right? In 15.1, we found the midpoint between 2 points. Really, we created 3 line segments here, and we found right in the middle of wherever that line segment was, right? It wasn't closer to D or closer to A. It was right in the middle, right? All of these points are right equally in between, equidistant from the 2 endpoints. What we're doing now with these weighted averages is we're finding a point that is slightly further away from A now, closer to B. That creates a 2-to-1 ratio. So we all know ratios from the beginning of the year from similarity, and we would write this ratio as 1/2. All right. However, that type of thinking is not going to work very well here, and I'll explain why. Well, if I think of 1 to 2 as a ratio of 1/2 of 1/2, that means I'm cutting the line segment in half, and that's not true. If I cut the line segment in half, both of the smaller segments I make would be equal. We don't want that. We want one to be twice as much as the other. Think about it this way. If I said I wanted a 2-to-1 ratio, let's say me and Miss Garcia were going in at the end of the year to discuss our pay raises, even though that's not something we can do. New York City teachers don't decide how much they get paid. But let's say they went in and, we're talking to our boss, and I'm like, hey, just want to let you know that I think I work twice as hard as Miss Garcia, so I think I should be paid twice as much. So we could say that for every $1 Miss Garcia makes, I want to make $2. Which, seems pretty fair to me. So what's tricky about that is when we create a fraction now, it's not just going to be 1/2. Let's say, for example, that at the end of the week we work really hard and they give me and Miss Garcia in total, that's not how you draw a dollar sign. They give us $3 in total. Out of those $3, how much am I going to make? Well, I'm going to make 2 of those $3, right? That extra $1 left over that'll bring it to a total of 3, that's what Miss Garcia is getting. So it's not a ratio of 1/2 or 2/1. It's going to be the first number over the total. So let me just make a general rule. If we have a ratio x to y, and I want to make a fraction for that for these directed line segments, my fraction is going to be x over x plus y. The first number in the ratio over the total of both parts of the ratio. So that takes a little bit of getting used to and sort of wrapping your head around, but hopefully this situation, which I'm sure Miss Garcia is going to love when she sees this video, is really how it works. Okay, so just like we did in the other problem, it is very helpful to create a right triangle. So if I'm going from A to B, that would be a right triangle that would make. And now let's find our change in x and change in y. So my change in y here, right, is going down 3. And my change in x, I'm going over 1, 2, 3, 4, 5, 6. Over 6. So I don't want to go all the way down. I want to go 2/3 of the way down if I want to create a 2-to-1 ratio. And it's important we're going from A to B because that's the order that they put them in here. So order is very important when we're talking about directed line segments. So instead of going 3 down, I want to go 2/3 of 3 down, otherwise known as 2, right? 2/3 times 3 is just 2. So I'm going to end up at that y coordinate. If I want to go 2/3 of the way over, I'm not going to go 6 over. I'm going to go 2/3 of 6. We know that 2/3 of 6 is equal to 4. So 1, 2, 3, 4. So now I find where those 2 points meet, and that's right at this coordinate here, which would be 6, 2. All right. I'll be honest. I really don't like the way they try and explain this in this textbook. So I'm going to sort of show you how I would have taught it. So there's a formula for directed line segments. All right, and there's 2 different formulas, one to find our x coordinate and one to find our y. So if I want to find my, let's call this x new, right? This is the new x coordinate. What I'm going to do is I'm going to take my original x, let's call that x OG for original, and I'm going to add my change in x. However, we didn't add 6 to this original a, right? If a was 2, 4, and we didn't add 6 to 2, right? We had to take the ratio first and multiply it by 6. So I'm going to take that change in x and multiply it by my ratio. We can demonstrate that here for what we did. I know I did it quickly and sort of in my head, so let me show you what was really going on. My original x coordinate, which is 2, plus my change in x, which is 6, times my ratio, which is 2/3. So that's going to give me 2 plus 4, aka 6. The formula for the y is going to be pretty much the same thing. I'm going to cross this out because we don't need it. Y new equals y OG, the original y coordinate, plus my change in y times the ratio. So if I want to actually plug in numbers now, my original y coordinate is 4. Now here, this is very important, and maybe I should have made this more clear. We're going down 3 in the y direction, so I'm not going to put positive 3. I'm going to put negative 3. Then my ratio is still 2/3. All right, the 4 stays the same. Negative 3 times 2/3 is just minus 2. 4 minus 2 is 2. And that is the y coordinate that we got over here. And, this is sort of, you can look at this a lot of different ways, like with anything in math. If I look at my whole segment here from A to B, all right, we want to weight the way we split it up. All right, I want to section it off, so whatever this length is, let's call this like a length of 2, the length from here to here is just going to be 1. Right, there's our 2-to-1 ratio. This length is going to be double this original length. And we can sort of see that in the rise over run as well. Down 1/2, down 1/2. I followed the slope twice. Down 1/2. I just followed the slope once. So we can really see that ratio of 2-to-1 a lot of different ways. But when you put it all together, it's really, this is 2/3 of the way. Right, this is 2/3 of the distance. And here, this is 1/3 of the distance. All right, and that's why it's weighted. We're not just taking the simple average, cutting it down in half. Each part has a different weight to it, a different amount. They're not equal. Like me and Miss Garcia, you know, I wouldn't necessarily call us equal. No offense. I'm just joking. I hope you all know I'm joking. Miss Garcia is the best co-teacher in the world. I'm very, very, very lucky that she's my co-teacher. Okay. So here now, for two new points, K and L, write an expression for the point that partitions segment KL in a 3-to-1 ratio. I mean, it would be nice if they gave us coordinates. So let's just give coordinates for each. Let's call K, let's call that A over B. Let's call L like C, comma D. All right. So if I want to find my X coordinate for the 3-to-1, that's going to be equal to my original X, so that's A, plus my change in X, so that's whatever the difference, that would be like C minus A, that would be the difference there. And then the ratio. Well, if my ratio is 3-to-1, that's really supposed to be 3 over the total. 3 plus 1 is 4. That's my ratio there. So that would be an expression right here. I could give it my new X coordinate. For my Y, take my original Y coordinate, that's B. Add it the change of Y, so D minus B. That's my difference there. And then my ratio, 3 over 4. And you know, it's much easier to see with numbers. This formula I don't think is very helpful. I think this formula is much more helpful, where we take our original coordinate and then we multiply or change in X by that ratio to find out how far we're going, right? Because the change in X and change in Y are really how far up and down we want to go. And so now we only want to go 2/3 over and 2/3 down.